All right, so let's do B, 2B. So 6 to the n divides into 20 factorial. So what's 20 factorial? I got to write that out. Bring it over here. 6 to the n divides into 20 factorial. So that's 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, and come down here, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is part 1. Part 1 is no calculator. So it's just, but these aren't hard numbers, right? Just 20 and on down. I promise I'm not going to give you really big numbers or anything. Now, what am I even looking for? I'm wanting 6 to some power to go into 20 factorial. So what's in a 6? 2 times 3, huh? Remember, it's all about primes, isn't it? All these things are about primes. Which primes on the left side are found on the right side is basically it, right? It's primes and primes. So if you take like 6, which is 2 times 3, to the like 10th power, for example, what does that mean? 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 10 times. In other words, that means 10 2s and 10 3s, doesn't it? So, for example, do you think 6 to the 10th power goes into 20 on down to 1? Well, how would it? If 10th power, 10 2s and 10 3s were on that other side. Are you with me? Does that make sense? Whenever one thing goes into another, left side and right side, that means the primes on the left are found on the right. It's as simple as that. Does 20 on down to 1, if you break all those numbers down, have 10 2s and 10 3s? I don't know. I can break them all down and see if there's 10 2s and 10 3s. And that would tell me whether 6, which is 2 times 3, to the 10 2s, 10 3s, goes into 20 factorial. So you're getting the main idea about one number dividing into another. If all the primes on the left, if it's got that much or more, it's like a container. Will it fit in? Does he have room over here for 10 2s and 10 3s? If so, 6 to the 10th will go into it. If not, it won't fit in. That makes sense? Now, do you think, if you start looking for 2s and 3s, what are you going to find more of? A lot more 2s. Every other number has a 2. Right? There's plenty of 2s. 2s are never the issue. There's less 3s. 3s is really the issue. So if we're wondering how many 2-3 combos are going to be over there, if you just find out how many 3s are over there, there's plenty of 2s to go with that. It's like a junior high dance, where there's way more boys than girls or vice versa. Right? It's whatever there's less of is how many couples are going to dance. Right? That's what we're talking about with the 2s and the 3s. Whatever there's less of tells me how many are going to couple up, right? So there's way less 3s. So don't even worry about the 2s. Just find out how many 3s are over there. So where do I find 3s? Does 20 have any 3s in it? No, 3 doesn't go into 20. 3 go into 19? No way. 3 go into 18? Yeah. 2 times 9, break 18 down, and 9 is 3 times, so there's 2 3s, found him in the 18. When I broke 18 down to his little bitty primes, he's 2 times 9, which is 3 times 3. So far I've got 2 3s found inside the 18. 3 doesn't go into 17, it's going down the line here. 3 doesn't go into 16, not evenly. Does 3 go into 15? Yeah. What's in 15? 3 times 5, so there's another 3. So far we've got 3 3s, don't we? On that right side. Everybody see what I'm doing? Keep going down the line. 14. 3 doesn't go into 14 evenly. 3 doesn't go into 13 evenly. 3 goes into 12. 3 times 4. There's another 3. What do I got now? 4? 4 3s. Let me get rid of this 10. The 10 stuff was just making up numbers. 3 doesn't go into 11. 3 doesn't go into 10 evenly. 3 goes into 9. There's 2 more. What do I got now? 1, 2, 3, 4, 5, 6? So far I've got 6 3s. Keep going. 3 doesn't go into 8 evenly. 3 doesn't go into 7 evenly. 3 goes into 6. 3 times 2. There's another 3. How many we got? 1, 2, 3, 4, 5, 6, 7. I'll keep track then. So far we have 7 3s. Keep going. 3 doesn't go into 5 evenly. 3 does not go into 4 evenly. 3 goes into 3, obviously. So there's another 3, and that's the last one. So we got 8 3s. we've got a total of 8 3s and plenty of 2s. I don't even know how to count them. There's way more than 8. So how many 2-3 combos can get together? 8 of them. Whatever, there's less 3s, so the 8 3s will tell us that 8 2-3 combos get together. So the highest power you can put here is, I'm on the wrong one, is 8. That's the highest power you could put there and have it go in. If you did 9, it wouldn't go in. Because 6 to the 9th would have 9 3s, and there's not 9 3s on the right side, there's only 8. So the answer is 8. That's the biggest power. Does that make sense how to do that? All right, that'll be on YouTube. 36, find the smallest in, so that 36 goes into in factorial. So it's again one number going into the other, which means it's all about primes. So let's break down the primes. This is 4 times 9, 2 times 2, 3 times 3. Okay, so what's in a 36? 2 2s and 2 3s, huh? 2 2s and 2 3s. So if we're wanting the left side to go into the right side, we got to find 2 2s and 2 3s over there, don't we? And it'll go in. Well, how do you know what in does that? Start guessing. Start guessing. It's a good idea. Let me start at like 3 factorial. It's got to be bigger than that, but let me just start there. 3 times 2 times 1. Would that have 2 2s and 2 3s? He's got 1 2 and 1 3. No, he doesn't have 2 2s and 2 3s. Let's go up the line. How about 4 factorial, which would be 4 times 3 times 2 times 1. Does he have 2 2s and 2 3s? He's got 2 2s right there. The 4's got 2 2s. In fact, he's got 3 2s, doesn't he? But only 1 3. So he doesn't have what we need. How about 5 factorial? 5, 4, 3, 2, 1. Does he have 2 2s and 2 3s? He's only got the 1 3. He's got plenty of 2s, but he only has 1 3. Next one, 6 factorial. 6 times 5 times 4 times 3 times 2. Does he have 2 2s and 2 3s? Yep, because now with the 6, we got another 3. And we got that 3. Two 3s and lots of 2s. So 6 factorial is the smallest. Why do we say smallest? Because if you went to a bigger one, like 7 factorial, that would work also, wouldn't it? Because 7 factorial would be 7, 6, 5, 4, 3, 2, 1. So anything bigger would also work, wouldn't it? Am I losing you? Right? 7 times 6, 7 factorial would also work. 7, 6, 5, 4, 3, 2, 1, because the 6 and the 3, we'd have the 2 3s. So that's why they're saying smallest. Find the first number that'll work. The first number that'll work is 6. Anything 6 or bigger will work. 6 is the smallest number that will work. Is that good? Want to try B there real quick? See about 80 going into, find the n that 80 goes into in factorial over there. Okay, so 80 going into in factorial. I'm going to break down the 80. 8 times 10. You can do all this without a calculator, right? These aren't big numbers. 2 times 4, 2 times 5. 4 is 2 times 2. So what's inside of an 80? 4 2s and a 5. 4 2s and a 5. So we got to find the smallest number on the right side that's going to have 4 2s and a 5. Factorial, So I'm going to start with 3 again. How about 3 factorial? 3 times 2 times 1. Does that have 4 2s and a 5? No, it doesn't even have a... I don't even have a 5. I might as well start at... 4 factorial is not going to work either because it doesn't have a 5. You got to start at 5 factorial at the least because you got to get a 5, huh? So let's try 5. You with me to there? That making sense? So does 5 factorial have 1, 2, 3, 4 2s and a 5? Does he have 4 2s? I don't think so. There's 1, 2, 3 2s, huh? He doesn't have 4. So how about 6 factorial? 6, 5, 4, 3, 2, 1. So now we got our 5. And do we have our 4 2s? Yeah, because 2 times 3, 4 is 2 times 2, and the plain 2. We have 4 2s and a 5. So the answer is 6 again. And that's how those work. Those one thing divide the other with the n factorial. The answer is always 6. You could just remember that. I'm kidding. I'm sorry. I'm just joking. It's not always 6. Is that good to there? Questions on that? All right. So adding, so again, this is no calculator, right? Because you all are going to teach younger folks to be able to do all this stuff by hand. So I'm giving you this part. No big number. I'm not going to give you 8,316 or something crazy like that. Just these kind of numbers by hand. Okay, want to try part A there? Go ahead and try part A. Add those fractions. Let's do a couple of those. See how you're doing on those. Okay, so what do you got to do to add or subtract fractions? Common denominator, huh? Multiply top and bottom of this one by 7. This one by 2. What do I get? Minus 7 fourteenths plus 8 fourteenths, 1 14th. Good? Remember all that stuff? Okay, so I think B is fine. Let's go on to C. Can you do C with the letters? Again, make the bottoms the same, right? Common denominator. Okay, so really I just need to, what do I need to multiply the left fraction by, top and bottom? Yeah, just the y, huh? And what about the right one? 2x. That'll make both of them 4xy. Does that make sense? And so then we'll get 5y over 4xy plus negative 14x over 4xy. And then you can just put them together. 5y minus 14x over 4xy. Is that good? You okay with the letters? All right, I'm going to move on to D, E, F here because I do want to look at the mixed numbers with you. Let's try D. We'll do D. So you got to make the bottoms the same. So give them whatever it takes, top and bottom, multiply top and bottom, to make the bottoms the same. Okay, so what does the first one need? Really nothing, huh? What about the second one? X. Third one? 2 and y. So then they'll all be 2x squared, y squared, huh? So it'll be minus 3 plus 7x plus 10y over 2x squared, y squared. Is that okay? All right, I'm going to go to E then on a fresh. Try E. I'm going to put it on a fresh page, but go ahead. The E and F, I specifically want to make sure you're okay with those. So try E. Start with E. Make sure you can. These are all again by hand, no calculator. I want to make sure that not just pushing the buttons, but you really know the operations by hand. E 1/10 minus 2. Okay, what'd y'all do? There's different ways. How'd you do this one, or how are you starting to do this one? Did you change the mixed number to improper, for example? That might be Probably a lot of people do that. I think it's a pretty good way. You don't have to, but it's probably a good idea. So remember how to change the mixed number to improper? So mixed to improper. Step one, multiply the denom, add the top, right? Remember, you multiply by the number on the bottom, add the top. So 2 times 8 is 16, add 1 is 17 over 8. Is that good like that? That makes sense. Remember, multiply the bottom, add the top. Okay, and now if I want to subtract those, now I can get common denominator. You could get 80 or 40. Really, 40 is the lowest. That'll make the numbers a little easier. But if you just did 80, that'll work too. You just have to reduce it at the end. It'll be okay. Either way, maybe I'll do 40. So just top and bottom by 4, top and bottom by 5. You did 80, that'll work too though. 4/40 minus, whoops, getting a little scribbly. Whoops, getting a lot scribbly. So 4/40 minus now 5 times 17. So I'll do this over on the side. That's not too big, right? You guys can do that one, 5 times 17 by hand. 5 times 7, 35. 5 times 1 is 5, add 3, 85. 5 times 8 is 40. Subtract those, minus 81/40. And that's fine, or you can make it back into a mixed number. Either, I'm good with either one. If I don't say, and I don't say on the test, then it's good either way. Or you can make it, minus 2 1/40. Either one, they're both right. And I'm good with either one on the test. It doesn't matter. How I changed that one, if you're interested, you probably remember, but you divide bottom into the top. Remember, that's how you change back in a mix. 40 goes into 81 2 times. Remainder once it's 2 1/40. You don't have to do that, though. It's not required. This is a great answer, or this. Either one. Make sense? Remember all that? On the next exam, on the exam we take Friday. So 5A, 6 9, 6 11s, 6 9s, 6 11s, 6 13s. Is that right? Yeah. Okay, and they want me to arrange in decreasing order. So decreasing order. That means high to low, huh? Decreasing, right? If you start with the highest, then it decreases as you go. So they want me to order high to low. High to low. So, okay, let me give you a second to think pie. I'm gonna eat some pie. I'm gonna eat 6 9ths of the pie. Thanksgiving's coming. I'm gonna try to have several pieces of pie. 6 9ths. My little daughter just went to a class to learn how to make pumpkin pies, so I'm ready. So, think about pie. So you're going to eat pie there. Think about, try to be real. How much is 6 9ths of a pie? Well, that's more than half a pie. Right? How much is 6 11ths? Just barely more than that. How much is 6 13ths? Right? So that's what this problem's a lot of is are fractions real for you? Are you sensing them? Are they not just numbers on a page, but do you get a real feel for them? Since you want to instruct others in this, they want to make real sense to you. So which one of those is the biggest amount of pie then? This one's biggest, huh? Does that make sense? He's more than half, right? 6 9ths is 2/3. It's more than half, isn't it? And then 6 11ths, that's barely more than half, right? You with me on that? Just barely. 5 11ths would be under half, 6 11ths, and 6 13ths, that's under. They're already in decreasing order, in other words. And we're done. The problem requires nothing. Barely. Did I write Brady? What did I write there? Barely above a half. And this is 2/3, really. Way above a half. So they're already from high to low, aren't they? I'm not going to need to rearrange anything. They're already high to low. So that's the principle there, that if the numerators are the same, a bigger denominator actually makes the number smaller. How about another way? Yeah, let me give you one more way. I want this to be as real as possible. That really is what you want. If you're going to be a teacher of fractions to kiddos, You don't want to just teach them monkey see, monkey do mathematics. That's really my heartbeat. For the 10 years I taught future elementary school teachers up at Stanislaus State in Turlock, and now as well, is really, math is not monkey see, monkey do. In other words, it's not just move things around without any feel. That won't be good. And you don't want to communicate it that way. You don't want to say, yeah, it's just a bunch of rules. You just move it here, move it there. There's the answer. That won't work. That will never develop future engineers or future architects or scientists. It's not, again, what they need to do is start to sense. I know it seems funny. I don't know if anybody ever talked to you about your math feelings. But you've actually got them. It's just about getting more in tune with them and helping others to be. So just be real. That's why I'm trying to be real here. Think about if you had 6 candy bars. Halloween's just right. I was talking about candy and pie here. 6 candy bars. See, I'm going to divide it among 9 people. How much of a candy? Each person will get 2/3 of a candy bar, huh? Now if you take those same 6 candy bars, 2 more people show up. Now there's 11 people. You're going to divide it evenly among those 6 candy bars evenly among 11 people. Do they get more or less candy now? Candy bar. Less. And then 2 more people show up. Now there's 13. They're getting less. Right? So as the denominator gets larger, there's less. You have to share among more. Each gets less, right? You know that, right? Same kind of thing. Decreasing order. See what you can do there. For sure, you can compare these two. I have no game plan like step 1, step 2, step 3, as much as I'm giving you a comparison. Right? These guys, you could make those have the same denominator, huh? And so that's where I would start here. So multiply top and bottom of this guy by 5, and he's minus 5/25. So you want to go from highest to lowest. But they're all negative, aren't they? So that's kind of confusing, isn't it? If 0's there, then the highest will be the least negative. So anyway, so here's minus 23/25. Here's minus 1/5. You agree so far? Because that's minus 5/25. It's not as far into the negative territory. Right? So this is negative 5/25. Negative 23/25 is more negative. Now, where does the negative, does it go in the middle? I mean, I don't know. What do you think? Does 11/16 go in the middle? Does it look like it sort of goes in the middle? It does, right? Did you feel that? This is almost -1, isn't it? And this one is not very big, 1/5. It's not exact, but that's a feel. Formally, you could get a common denominator between these two. If you wanted to formally be sure, you could get a common denominator. You can see how I'm just common denominating 2 at a time? Because I don't want to try to get a common denominator for all those. It would be some gigantic number. We don't have a calculator on this part, right? I don't want to do that would that work? Yeah, sure, that would work, but that'd be a big number. I think that'd be 400 or something. Yeah, 400. That'd be big. We don't want to do that by hand. So instead, you see how I'm just doing common denominator for 2 at a time to make life simple between comparing? So I just did the 25 and the 5. That was obvious and easy. Now, how about the 16 and the 5? Well, I could multiply this one by 5. Whoops. And this one, and now we'll go back and multiply this guy by 16, top and bottom. 5 times, that'd be 80. They'd both be 80. This would be minus 55/80. This would be minus 16/80. Yeah, so the minus 55 is certainly here. This minus 11/16 is further negative, isn't it? Right, it's more negative than that guy. Like we thought, our feeling was right. So there's the order now. But who's actually the highest then? Here, let me move this up here so I have room. So having done my list, we all good. I put them on the number line.
Everybody good with what I did there on the number line? Here's 0. Here's 0. So there they are on the number line. So which one's actually the highest number of those? This guy, right? Because he's the least negative. So watch out. Negative reverses everything. Basically, just remember it reverses it. Right? Because he's the least negative, followed by the middle guy, followed by the other guy is the most negative, so he's the lowest. So there's the right ordering. Does everybody see what I did there? Basically, my game plan was to get common denominator 2 at a time, wasn't it? And compare that. I did 25 and the 5, I did 16 and the 5. Common denominator 2 at a time. All right, I got to move on, but I'd be glad to talk about that with you in office. Okay, so yeah, how about 6a there? Can you look at these fractions and feel what they're going to add up to be about? Again, this is no calculator, so it's helping you to feel things. How so? How do you feel? What am I talking about, feel? Well, 6/25ths. We don't want to do a bunch of by hand hard number stuff. We don't got time for that. You're not going to have time for that in the test. It's not, you have no calculator here in part 1. But as you look at 6/25, what is that about? Like, what is that close to? Instead of 25, what number could I make that 6 does go into that's real close to that? Remember, this is just approximation. 24, huh? What if it was 6/24? That's a fourth, isn't it? Do you see how that fraction's really close to a fourth? Because if it was 6/24, that would be 1/4 exactly. It's super close to that. So that first fraction is about a fourth. Do you see how I'm getting numbers that are close to get an approximation. Now what is 25 over 101? What is that really close to? 25 out of 100, right? And that's a fourth again, right? If you have 25 cents out of a dollar, that's 1/4 of a dollar, 1/4. Good? So those two are really close to a fourth. Okay. Now, these two, I don't know. 7/30ths? 17/70ths? I don't know. What do you think? Anybody got any good ideas? Those are ugly numbers. I could add them with but that's ugly. I don't want to multiply 29 times 69. I got time for that. Let me tell you what I do. I look at this. Again, I'm sorry I don't have step 1, step 2, step 3 here. This isn't mainly about steps as it's feelings, which I know that can seem abstract. But I'm looking at this and saying, look, it's about half of that. Sort of. Not exactly.
7/29 is like a quarter too.
Oh yeah. I like your plan better than mine. I have a crazy plan. Yeah, yours is a good one. Good, yeah, because that'd be 28, huh? Good job. I just didn't see that at first. Yeah, good job. 7/28 would be a fourth, right? 4 times 7. So yeah, good job. That's another 1/4, huh? Okay, now what about 17/69? I don't know. Let's go. My hunch is 4 again. Let's take the 4 times the 17 over on the side and see if it comes out close. 4 times 7, 28. 4 times 1, 4, I do 68. Yeah, 17 over 68 would be exact. So that's also close to 1/4. They're all really close to 1/4. 1/4, 1/4, 1/4, and 1/4. So what does that add up to be? About 1. Right? 1/4, 4 times. That's really close to 1. Is that good? So just try to find it. They're not going to make it weirder than that. Yeah, so I like what you did. Thanks. That's helpful. They're going to end up being a half or a fourth or 3/4 each. They're not going to be any weirder than that. So this estimate, approximate ones, try to figure out if each of those fractions, or 0, could be close to 0, or 1, or a half, or a fourth, or 3/4. It's going to be in quarters. It's going to be somewhere in quarters. All right, let's do the next one. So what about this one? What's that close to? 3/4. Okay. What about that? What's that close to? That's basically 0. That's like, if you take 3 candy bars and divide it among 1,000 people, they each get almost no candy bar, right? So, and what about this one? That's 0 also. These add up to 3/4 basically. Do you see that? So again, each of the numbers is going to round off or be really close to 0 or 1 or some kind of 1/4, 3/4, 1/2 thing. All right, we'll move on. 9. All right, so how do you take 9.5 and write it as a fraction? What do you do with 9.5 to make it like a fraction? Yeah, it's 95 over 10. Do you remember how that works? Whatever the ending place, and you can reduce that, of course, but yeah, I just want to show you that. So whatever the ending place, so how did I write that before? So remember that, so you have the decimal, you have 1, 2, 3, 4, 5. That first place is the 10th place. The next place is the 100th place. The next place is the 1000th place, etc. So whatever the ending place, that's the denominator, isn't it? So if it ends one place to the right, one place is the 10th place. Okay, let's try the next one. 28.4. What's 28.4 going to be as a fraction? Yeah, you write the whole number, 284, over. Where does it end? First place to the right. Tenths again. Tenths again. So it's in other words, however many places after the decimal is how many zeros. How about that? That's another way you can say it. If there's one number after the decimal, there's 1 0. 10. One number after the decimal, 1 0. Right? It ends in the 10th place. Okay, and how about C? Can you do, or the third one, 0.47. So that's going to be 47 over 100, because it ends in the hundredths place. 2 places after the decimal, 2 zeros on the bottom. Now, they want you to do something else with these. What? Write the decimals as fractions and then add. Yeah, they want you to add these up. So how would you actually add these up? On the test, by the way, let me just be clear. I'm not going to have you do the rest of this. So I'll show you. But on the test, I'm just going to say, here's the decimal, give me the fraction, done. No, it'll just be like maybe 1 or 2 of them. It won't be 3 parts A, B, and C. It won't be this long. It'll be like 1 of them probably. And it'll be 1 decimal, maybe 2. And it'll say, change to fraction, that's all. So I really just wanted to make sure you can change a decimal to a fraction. Are we good with that? And so I don't know what, you're all a little different. Okay, so yeah, I'll show you the rest of the problem, but you're not going to have to do any more on the real test Friday. This will be all we do, stop. Actually, you'd have to reduce that fraction, huh? That fraction's not reduced, divide top and bottom by 5. But anyway, I'm not going to do that here. Here we're going to add these guys. If I'm going to add them, I need common denominator, don't I? So I need to multiply top and bottom of this guy by 10, top and bottom of this guy by 10. Why? Because 100 is the biggest denominator. So I'm going to have to make them all hundredths. Aren't I? Let me bring him down. Kind of ran out of room there. He was 47 over 100. So for the Math Excel, for the practice exam, you'd have to make this 950 over 100. This one in the middle is 2840 over 100. This one stays the same. Then add those up, so you would just add up. You're not going to have to add up gigantic numbers like that on part 1. So just use your calculator. Finish it up. On the real exam, you won't have to do all this stuff. All you'll have to do is get the 47 over 100 or the 95 over 10 and reduce it. You would have to reduce it, divide top and bottom by 5, right? To take the 95 over 10. I would ask you to give me a fraction. So divide by 5. You can long divide in the side of your paper. Be 19 over 2. You know what I mean? 5 into 95 goes in there 1 time. 45 goes in there 9 times. Right? 19 over 2. So that's all you're going to have to do on the real exam, is just give me the 95 over 10 and reduce it to 19 halves. Just want to make sure you can go decimal to fraction by hand. Questions on that? Okay. So how do you multiply to scientific notation? Oh, that's weird. To multiply these guys, we go 5 times 7, 35. You can do that by hand, right? 5 times 7, 35. Times 10. And what do you do with the powers? You add the powers. Yeah, remember powers add? So you just go on the side of your paper, 15, 17, 12, 32 to the 32. And that is almost right. It's just got, if you left it like that, I probably would give you maybe 1 point, maybe 2. There's one other thing we have to do. You get like half the credit, maybe 1 point or 2. One more thing. Why is that not right? That's almost right. Yeah, scientific notation means the decimal has to be after the first digit. Where's the decimal? I don't see any decimal. Where's the decimal right now on the 35? Yeah, if you don't see a decimal, it's like a period in a sentence. It's always at the end. It's really right there, huh? So we're supposed to put it like that, aren't we? You with me? The decimal's supposed to be after the first number. That's what scientific notation means. So do I just move it there and just leave it 32, or what do I do? Yeah, we got to change the power. How do you know which way to change the power? Remember we talked about this? You guys never forget anything I say in here, right? You watch these things, YouTubes over and over again all day long. Play them on your phone with your earphones in as you're in your other classes, ignoring those other unimportant classes, right? No. All right. Yeah, it's a little tricky. It is a little tricky. Basically, anybody remember the trick? It's kind of tricky. Basically, the idea is we can't change the number. We're only changing the way it looks. So if we make one part smaller, we got to make the other part bigger. Therefore, overall, no change. So if I move this decimal back, I made that smaller. I made it from 35 into 3.5. That's smaller. So if I make that part smaller, I got to make the power bigger, so that overall there's no change. If you make one part smaller, you got to make the other part bigger. Then you haven't changed it really. You've just changed the way it looks without changing the value. Does that make sense? So if you make the front part smaller, you got to make the power bigger. Then overall, you haven't really changed anything. You've just given it the right look, the scientific notation look, which means decimal after the first digit. Remember that kind of thing? Let's try B. So B is a divide. I don't know if you can see that. It's a divide symbol. Oh, yeah. It's good on the big screen there. So that really means, let me write it vertically. You don't have to, but it might be helpful. It's like that, huh? So how do you do that? The numbers in front divide. 6 divided by 3 is 2. And then what do you do with the powers? Powers subtract. 11 minus 5 is 6. And that one's good, huh? We don't need to do anything fancy at the end of that one. Why not? Why do we have to mess with the last one? We don't have to mess with this one. Yeah, because where's the decimal right now on the 2? Well, it's at the end. It's right here. Which is perfect. It's after the first number. That's where it's supposed to be, so I don't need to mess with it. Whereas the 35, the decimal came out in the wrong spot at first. On that, right? C is the same thing, just multiply and then divide and subtract. Estimate the percent of the square. Can you do that by hand with no calculator? So figure out what percentage that is. I would start with a fraction. Just start saying what fraction. First find out what fraction, and then change that fraction to a percentage. So what fraction is that? If this whole section was shaded, like if all of this was shaded, that would be what? What would that be if that whole section was shaded? What portion? That'd be a fourth. Or 0.25. Yeah, you guys are just thinking, well, that'd be 0.25 or 25%. That's what you're thinking? Yeah, you guys are doing a different approach. That's actually a better idea than I had. Yeah, let's just do it that way. I like your idea. Yeah, if that whole thing was shaded, that would be 25%, huh? But only half of that is shaded, so divide by 2, huh? Yeah, good idea, guys. Yeah. 25%, so half of that you just divide on your calculator. 2 into 25, 2 goes into 2, 1 times 2 is... Do you remember how to long divide by hand? 2 goes into 5, 2 times 2 times 2 is 4, remainder 1, so it's 12. It's 12 point... You could add a decimal, bring it down. 2 goes into... Remember about adding decimals? Am I going too fast? Do you remember all this long dividing stuff? So when you get down to 1, if you want to write a fraction, you go 1 over 2. But if you want to turn it into a decimal, remember you add the decimal with the 0 and bring down the 0 and keep going. Remember how to do that by hand to get decimal? Then 2 goes into 10, and the decimal goes straight up, doesn't it? Remember, the line up matters, the place values. 2 goes into 10, 5 times. 12.5%. Yeah, that's a good way to do it. I like how you did that. Now, what if I gave you, let me do one other thing. Yeah, I think, no secrets with me. I think on the real test, I gave you something like, I don't remember what it is, but it might be like 1/8. I just give you the fraction. How would you turn 1/8 into a decimal? A fraction. A percentage, sorry. It is a fraction. A percentage. Sorry, I'm running out of time. Remember how to do that? You just long divide bottom into the top. Now, 8 doesn't go into 1, so what do? You make it look like a 10 by making it 1.0. It's still 1. And then you go 1 times 8 is 8. 2, bring down the 0. 8 goes into 20 2 times. 16, 4, bring down the 0. 5 times 8 is 40. So it's 0.125 as a decimal. Then turn it into a percent. Decimal moves 2 places. Same answer, huh? Because that is 1/8. So make sure you know how to go from fraction to percent as well.